We always think that to make an AI smarter, it's got to get slower, right? But what if that's just wrong? Today, we're going to dig into a really cool new method for AI reasoning that completely flips that idea on its head. It promises to deliver better answers and get this, do it faster. Let's dive in. So think about it. Right now, the standard playbook to get a better, more accurate answer from an AI is to just make it think longer. You tell it to generate this massive, rambling chain of thought. And that, right there, is a massive problem. Are we just trading speed and cost to get a little more accurate? Is this whole chase to make AI smarter just making them too slow and expensive to be practical? So yeah, this is the big hurdle that researchers are trying to get over. It's this fundamental trade-off that's just been baked into how we do complex AI reasoning for a while now. Okay, so this standard method, people call it long chain of thought, or long COT for short. On the one hand, it's got a clear benefit. It lets the model kind of wander around, explore different solutions, and even check its own work, which usually leads to a more accurate answer. But, and this is a big but, the downsides are pretty rough. It's incredibly slow, what we call high latency, which means you're just sitting there waiting for an answer. It also jacks up the cost, and for really, really complex problems, it can just fall flat on its face. So that's the million-dollar question, isn't it? How do you get that high accuracy without just grinding everything to a halt? Well, the solution requires a totally new playbook. It's a fundamental shift in how we even approach AI thinking. And this quote from the paper, it just nails the core idea. Instead of seeing the AI as just a linear thinker that spits out one long answer, you reframe it. You see the model as an improvement operator. It's like the AI isn't just writing an essay from start to finish. It's becoming its own editor, actively working on and refining its own ideas. And this new playbook has a great name that tells you exactly what it does: Parallel, Distill, and Refine. Let's break down what that actually means. All right, so here's how it actually works. First, instead of one long thought, the AI just spits out a whole bunch of different solution drafts, all at the same time. That's the parallel part. Then, it looks at all those drafts and distills the best ideas, the key points, into one short, powerful summary. Finally, it takes that summary and uses it to refine its work and write a single, much better final answer. Honestly, the best way to get your head around this is to think about how we work on a tough problem. Step 1, parallel. That's your classic brainstorm, right? Everyone's shouting out ideas at once. Step 2, distill. That's like taking all those messy brainstorm notes and creating a clean, crisp outline, capturing the best points. And step 3, refine. Well, that's taking your awesome outline and writing the final, polished paper. It's the same process. Okay, so that all sounds really smart on paper, right? But the real question is, does it actually work in practice? Well, the results are where things get really, really interesting. Let's see how this new method stacks up. So they tested this on the Amy 2024 math competition, which is, notoriously hard. And the PDR method, it delivered an 11% boost in accuracy over the old way. Let me tell you, in this space, 11% isn't just an improvement, it's a huge leap forward. In this chart right here, it just makes that so clear. Look at that, PDR is hitting almost 87% accuracy. Meanwhile, the old long-cop method is stuck down there below 77%. That 10-point difference shows this is not a small tweak. This is a fundamentally better way to get to the right answer. But wait, accuracy is only half the story, right? To really get what's going on, we need to look at two things. First, there's B-seek. Just think of that as wait time, how long you're staring at the screen waiting for an answer. Then there's B-total, which is like all the brain power the AI uses in the background, including all those drafts it threw away. And check this out, this is the first big win. When you look at latency, that wait time we just talked about, PDR is way faster. That much lower bar for PDR means you get your better answer and you get it sooner. So a smarter answer in less time. Okay, but here's the other side of the coin. See, PDR does use more total computing power. I mean, it has to, right? That whole brainstorming step where it's creating tons of drafts at once, that takes more raw energy. But it's a really smart trade-off. It's using more effort, sure, but it's doing it all at once, in parallel, specifically to save you time. And this is really the key takeaway from all of this. PDR is basically taking a bunch of parallel compute, something we have a lot of, and turning it into a better, more accurate answer that gets to you faster. You get the best of both worlds, smarter results without the agonizing wait. But it gets even cooler. This isn't just some clever trick you apply to an AI after the fact. The researchers realized you can actually train models from scratch to be amazing at this way of thinking. They call it operator-consistent training. And what that means is you're not just teaching the AI to write one long answer, you're building the skills of brainstorming, outlining, and refining right into its DNA, right from day one. It becomes a core skill, not just a neat trick. And the numbers here really speak for themselves. Look, if you take a standard model and just bolt on PDR, you get about 63% accuracy. Okay, a more advanced model gets that up to nearly 76%. Not bad. But look at that bottom row. A model that was trained using the PDR method from the very beginning, it jumps all the way up to almost 81% accuracy. This proves you can actually teach an AI to be a better parallel thinker. And that really leaves us with this incredible question to chew on. What we're looking at here is a way to teach an AI to think like an entire team of experts, all at once. It's not just one thinker. It's a whole brainstorming session happening inside a machine. So, what's truly possible when a single AI can reason not as one mind, but as a whole team?